use a Pi-Day.org. Yeah, they gypped me. I wanted 1 million, they gave me 51,000, thereabouts. So I went off to PyDigits HTML and learned trust but verify. So, download from 2 different sites, compare the files. And also, let's see if yeah. So, write a little program, and now I didn't do TDD on this one. This was, hey, main file reader, file name, file reader ready. In other words, is there something to read? Read the character, increment the count, spit it out. Let's see if this will work.
Possibly go wrong.
Well, yes. Boom. The answer is 1 million digits. So I did find a file, I did verify it, and now I've got something to compare against. All right. You already saw string builder assumption about ease of use. Yeah, not an optimal assumption, so let's change that out. Decimal point, don't want a decimal point, so I just remove that. The algorithms that you find online, so, okay, flag, if this is the first time through iteration, okay, great, flag false, so put the decimal point, flag true, and you're always doing that. So, okay, I don't really care. I'm just calculating digits. And, yeah, that first or the second character sequence of pi, I think I know it's a point, and I'm not going to show this to anybody in the calculator. And I didn't want system out. How do I know I'm doing it well? Visual VM. Anybody hear of that? It was eradicated in JDK 8. They just shot it down. It's gone. But there's an org out there. Visual VM GitHub.io. Give you a new Visual VM. Download the plugin for IntelliJ, and voila, you got Visual VM. And you can see the spigot thing I ran here, 4 minutes and 29 seconds, and a gradual memory uptake. We all knew that. I'm storing the answer within the program, and the program, you have to feed it the number of digits, and it creates a new array of a large number of digits so that it can do all its error correcting. And so everything is stored in memory. And this kind of went against what I wanted to do. So got an algorithm, it works a little bit, I kind of understand how it works when we're looking at the formula, but it's not doing what I want. It's not a true spigot. It's in memory and collecting everything. So, search continues. I found calculate digits of pi on Code Katas. That was okay, but was still in memory. A book, Pi Unleashed. Well, okay, it's got some algorithms in there. In fact, you can read most of it online, but the section that you really need, which is showing you the code, so didn't want to buy the book just yet. And then, Rosetta Code. It's like, eureka. How many people have heard of Rosetta Code? Couple. Okay, so takeaway for tonight, everyone else. Rosetta Code. Really cool site. So let's go. There. Right. There you go. Love the icon. It basically has problems that are solved and puts them into each of the languages. So actually very cool. And just happened upon this, but if I go into languages, you can kind of see the total number. It's got a lot. Okay, so let's go to Java. Boom. And now in Java, you can see what's it using. Everybody remember the discussion last month, OpenJDK versus Oracle? Everybody clear upon that? Everybody paying for it, or you going for free?
Free.
Free! That discussion is still going online. It's like, I'm not sure where people will have to understand. JDK is free. JDK, not a problem. You're just not going to get any more updates from Oracle for free after that. Use OpenJDK, great. Use any version you want. If you want the most supported version, you're up with, I think we're at 11, and 12 comes out in March. So bug fixes aren't happening. It's just, they have a release, the major release every 6 months, and they have a kind of a minor release probably a couple weeks later. I think we're at 11:01 right now. Does anybody know for sure? We can find out. Not there. I spelled it right. There we go. Uh-oh. Now this one doesn't do the zoom function very well. Can you read that, Barbara?
Version 11,
Version 11.
2018 09 2085.
Okay, so I'm not even 11:01. Oh well. Okay, to Rosetta Code. All right, and here again. Pi. Okay, let's find Java. There we go. Okay, now something actually readable that looks good. And does it work? Actually, it does. What was more interesting is taking a look at the other stuff. So here, in my quest to understand, there's just no comments. But it's translated from icon. But before that, Kotlin. Because we have the Kotlin guy here. Translation of Java. So yeah, it's actually, it looks a lot more readable, doesn't it? So, okay, this is interesting. So Kotlin, a little bit more readable, but let's go back. We want it to go to icon. And we see it's based upon Jeremy Gibbons' Haskell solution. So now the research has gone full circle. We finally got, okay, what is the algorithm, and they're doing it. But this one doesn't have a very good explanation. And let's see. Is that a code? Yeah.
Can I see the J?
The J, absolutely. It's before Java. There we go.
Yeah.
So, send out 03.1, do wow. That looks really simple.
Very concise.
Very concise. How far will it go? And do you understand that symbol there?
Is that a label?
I have no idea. Does anyone want to look at the Perl? Okay, Gins and Griggles. Perl. They use the arithmetic geometric mean to calculate pi. There we go. That's not too bad. And here's the Perl 6 spigot. A little bit easier. So, in reading through it though, I found a bit of language code that actually talked, had comments within the code, which, we all talk about, well, should we have code comments or not? When you go into a public site, code comments are enormously nice, explaining what's going on. Otherwise, it's like really difficult. And I was just, oops. I was really happy that they had put comments into at least referencing back to the algorithm, Gibson's algorithm from Jeremy. So otherwise, it would have been a long day trying to figure it out. Okay, so let's go back into, so we're in here. There we go. Lots of languages based upon gibbons. Show the code and the values. So let's get there. Okay, so this is the stuff. Very concise, calculate pi digits. I put in the collector here again, TDD. You can overwrite the system out function and replace it with something else, but it's like, okay, why bother? I'll just throw in a collector of my own doing. Yeah, I did stream builder again. But I did do the output digit function. So up here, once you get through, you output the digit. If your collector is not null, append the digit to that collector, you're good to go. Otherwise, system out it, because you just want it to roll off someplace else, or you want to pipe it someplace. So kind of get that functionality. Now, this is kind of going back to that, you guys remember the PDF and the obfuscated document stuff? Well, that's what people implement. So it was a QRT, and there's no explanation for what those things are. You just do it. The big integer values here again using Java's big int value. This is all kind of nice arithmetic to get things done and not worry about losing the precision, which was what was all key.
Those correlate to an equation like PDF, maybe?
Yeah, it's let's see if I still got the PDF is up. Not precisely. Let's go. That's on that screen. Good. And then it's about midsection down here. So here you can see the pi is equal to this. So there's your QR, TK, N, 4-star that, then that, else this. Write that equation, you're good to go.
If you go up to the original, like, yeah, right there, if you zoom in on that, it's, all right, there's an I. No, okay.
Yeah, no, it doesn't make sense.
Sorry, never mind.
So that is, here again, got the system to work, kind of did the proof, the kata, it's working. Still trying to make the connection between the actual algorithm and how they solve the problem. And this doesn't do it for me. And in fact, you go on down, well actually it's this one, and let's see, algorithm made them, yeah, here we go. This one says as memory will allow. And we'll come to that picture in a moment here, and you gotta keep track of time. But they talk about the Haskell aspect from that Rosetta Code. So this is the part that he used, the integer arithmetic, trying to solve the memory problem. And I don't think I get any further on the actual code yet. Let's see, streaming algorithms. Here we go. So the algorithm streaming for pi, and you would think, okay, great. You could stream that and never run out, but here again, this gets even more obscure using the matrix annotations type stuff, what they're trying to do. So it's going to take a little bit more research to figure out how the algorithm is working. I did write it out longhand just to take a look at it. But it's kind of like the variable naming. They're just characters, and I can't relate them to anything in the algorithm, the paper, what they're talking about. So
QRST.
yeah, they just
No, I mean, they're defining it as an algorithm, they're good describing
What was interesting too is the use of the constants. So here again, it's kind of like you're deciphering stuff. So we know we're going to use 2, 3, 4, and 7, and they're and 10. So those are the constants. You would expect those to be somewhere in the algorithm. Here again, it goes back. Now you can see 2, 4, 10, and 7. That there's a 5. But it'd be one of those things. Kind of work it out by hand, so you can understand the connection between the two. Or else just write the program yourself and see if you go from formula to algorithm within code.
it. I think it's right there, right? 3.14, and then there's a 1 and a 5, that's easy.
Thank you, sir.
It's good.
Okay, let's see. And, oh yeah. This loop isn't a digit loop. In other words, this will happen, the original had just a while true, infinite loop, so it'll just go on until you control C or terminate somehow. So stuck in this because I wanted the, specify a number of digits and count the digits, and the digit counter is in the output. So whenever, we did this, output the number of digits, increment the counter, and now I have precise control over how many digits we're going to output. And that was important for the test guy, which I think I'm missing. Big pie test. There you go. So here again, 1,000 digits of pi as a string. Create the guy, calculate 42, and then calculate 1,000, and just do a containment on 1,000. So let's go ahead and run that. Right. And can I zoom? Yay! So there's pi to, so what is this, system printout, 1,000 digits. Voila. So basically giving confidence that the code is going to work. Now, let's see, if I were to put answer to strings, 0 digits. Proof that there is a result not contained in pi. Okay. All right. So now, on to the big int and performance. So I did, show you the, downloaded some pi digits and had to make sure, verify the answers, so I did 1,000,000 and thought, well, at first I thought I had 1,000,000, so I let the code run for 3 hours and then realized that it's calculating 1,000,000 for me, but the result set I got wasn't 1,000,000, so I had time to go and find the correct result set. And that's what these, bring up the visual VM, by the way, that, let's see, I have to get into calculations back into hundreds of thousands to bring that up, but it does work. So, go back there. So big pi, if I run this guy, this is the Shift F10, big pi, edit, So there are no options here on to calculate pi. So what's it gonna do? It's gonna fail. And we need to give it something. Okay, so give me a number of digits, anyone.
20,000.
20,000, okay. And there she goes. And we go here. There's Big Pi. And there we go. So now I've got insight into CPU usage and it's streaming off digits. Don't really care, mainly because I did it. And I had to use some PowerShell, so figure out how to type it out, measure character and lines. Can you guys read the fine print in the back there? In blue? Not really. Yeah, basically it's telling me I'm up to 300,000 characters. I'm up to 419,000 characters. I'm at a little over 500 megabytes of heap. CPU constant around 18%. I'm at 800,000 and I'm at 21 hours. So I was able to do a little statistics and figure out when it would get done. I put in a time function, or just throw in the date. So, Sunday around almost 6 o'clock, I'm at 995. Notice the memory jumped up a little bit here. So somewhere between 21 hours and 27 hours, something happened. Okay. Now that might be interesting to figure out where's the memory leak in this. Because big mess mode, it will grow pretty much as big as it needs to get to maintain its accuracy. So somehow it's storing larger and larger numbers. And this gets back into understanding the algorithm and how it's working. Then we go back to Visual VM. This guy is done. So you can see he just eradicated over. He ran for 8 seconds. And pi is stopped. Somewhere way over here. So there you go. The last 4 digits of a 20,000 sequence is 5517. And not too bad as far as how long it took.
Why does it use so much memory for them that long of a string?
For 20,000,
500 megabytes or?
well, this one was using 300, it maxed up on the heap. What is that?
This implementation isn't doing the string to store the data, right? It's using a big integer.
Right. It's not storing the data. Here again, the spigot function is to basically,
It's just streaming.
it's just
Yeah.
calculating it, but it does have to fill up
Has
these
to have
digits. So,
A number of these big
right.
integers.
These guys here start out as 1 and 0. But after that, they're storing numbers that basically, next value of R is 10, the big integer 10, multiply R, subtract N, multiply T. Okay, great. So that's just going to get bigger depending on what N times T is.
All those numbers are going to grow in memory
Right.
as you're doing larger digits.
Right. So the aspect is that there's still memory growth, memory usage, but it's not as big as the other algorithm, which has to store the entire sequence of memory because it's cycling through it for its error correction. It's doing it. So the initial spigot algorithm, which is this guy here, let's see, parsing it, read line. Size of memory is 10 times the number of digits you want divided by 3. And the remainders is that big. And then your pi digits, where your output is that big. And then it's going to sequence through the remainders each time from, the size. So here is where, if you want 20,000 digits of pi, you got to create an array that is at least 200,000 divided by 3. So then you got just, you can still get a really big number of pi, but it's all going to be in memory. The big disks with the big ints basically do similar thing, but only as they grow into it. And that's why I saw the stepping function of going from 500 to a gigabyte, basically. Over 27 hours, that was kind of interesting. It was just the interesting aspect was just watching this stuff, as a zigzag, but pretty well maintained. Now, it could be is that I can go back and isolate where it jumped up in size and figure out what happened there. Might be interesting. Let's see.
So that's a gigabyte?
Pardon?
That's a gigabyte?
Yeah, just a gigabyte of heap.
But it's going, if you zoomed in on that, it's good constant. So it's because of all that. It's not, you're not using a lot of memory, you're just creating a
Well, yeah, if
whole
you.
ton of big integers and then garbage collecting, right? And then
Yeah.
creating a bunch of garbage collecting.
So if I go to the visual VM, the thing we didn't look at here, I'm not sure if it'll work.
Like it's just garbage collecting, lazy, when
Yeah, and that's the thing is that when you run it, in fact, let me go ahead and rerun it. Can you rerun it from visual VM?
Oh, so it's just using that memory because it can?
Yeah.
Well, if you go
Well,
back to
I mean-
if you go back to the code, like every one of those big integer dot multiply dot minus is a new big integer. I think there's a pool, right? He keeps a pool of like the first, I don't know how many,
Well,
256, 512, something. So every time you make a number bigger than that, you're creating a new object.
Right.
And then you're, like NR, you keep reassigning NR in the loop, so.
yeah.
Plus all the ones on that statement, so you're gonna be creating dozens of big integers every time you go through this loop or more. And then when you're done with them,
again.
you're gonna reassign on the next loop, so they're all just there to be garbage collected. The garbage collector's only gonna run when you start to reach, when it's either not doing anything or start to reach the max.
Yeah, so maybe it was a change in the garbage collector that made it go up higher. Like it was trying to keep under 500 for a while and it gave up on it for 21 hours. And then it finally gave up.
Okay, here we go.
VM version of the garbage collector on the side.
So you can
Yeah.
see the int array is the max guy here, 360 million. That's bytes, 360 megs. I think we're done already. Jeez, that was quick. We can do something bigger. Yeah. Did I miss it?
Is there a refresh or-
Okay. I'm looking to see if there's another visual VM out there, but not showing. we go. Go to the simpler memory. And there you can see as it grows, it will grow these
it's
ints, and then
growing.
they get garbage collected, and that's
Yeah.
what we see on the monitor here, this up and down garbage collection. And then eventually, it's got to, whatever the int array is that's supporting the big guy, just has to get bigger, and it does that, more allocation. So that's why we get the better precision, is that it's all under the covers as far as that integer is concerned. All right. Yeah. So this is when it finished. I was really happy, and you can see I kept the 1,000,001 digit that came out of the web, so I can see the final count there by doing the file compare program. So I was quite happy that the calculator calculated pi, and that at least I got 1,000,000 digits of accuracy after 27 hours.
27 hours.
20, yeah. We'll just let the computer run and burn electricity, right? Okay. The conclusion, what you've all been waiting for. Okay. So, Katas, it has the benefits, but it's like physical exercise. Keeps you in shape, keeps your brain going a little bit, you ask questions, do something that you find interesting. That's why I kind of picked pi. It was like one of those little pet things in the back of my mind is pi. It should be so easy to do, but it is slightly difficult. And it's kind of got an interesting history. And there are people, that are doing this stuff. 22 trillion digits. Wow. And who's going to prove
Because
it?
it's there.
It's there, yeah. I don't want, I mean, somebody calculated it was 2 quadrillion digits. Okay, that's like way out there. Well, why not just, somebody wants to test out their new quantum computer. Okay, TDD leads the way. So here again, it's just a refresher. I think a lot of the online stuff where it says, solve this problem. Okay, you got to think about it. Sometimes if they give you the tests, it kind of guides you in, okay, great, I know what I'm supposed to solve here or there. Breaks the problem down. But also, if they don't, then you can break the problem down using a TDD concept. Take an existing formula and codifying it, and then add to that readability. This is the thing, when you go online and find somebody else's code and it's not commented, it's out there, and it's like, okay, what's it doing? So now you can just go in there and investigate it, write the test, see what it does. How would you like to do it? And so, back to that practical question, why pi? Well, it was fun, it was interesting, kind of gets you back into the groove, the rocket equation. Now that's something that's practical. Just take a look at Elon Musk and SpaceX. Single stage to orbit. Why can't we launch one rocket, one stage? You remember this? Yeah. Why can't we get off the ground? If you take a look at SSTO on the History Channel someplace, you'll find that we were all developing this little thing, and it went up, it hovered, and it came back down, and one day it crashed. Strut broke, and it blew up. And it wasn't a full-size rocket, but it was still pretty cool. Elon Musk has got the takeoff land bit working, but you can't get off of Earth due to gravity. And that's the rocket equation. So you need 2 stages. And so, there's a practical example in there that might be an interesting kata, just to start codifying those equations. And I'm interested in it, so that's cool. What's your interest? Yes?
I don't know if you guys ever did a Quine, the challenge where you have to make a program whose output is itself, the source code, without using any external files. And I had a college professor who said, if you do this, you get an A in the class. And I couldn't do it. And then 14 years later, I was sleeping at home one night sick, and it just solution came to my head. I wrote it out and I found them on Facebook. I was like, hey, I came up with a solution. So, you know.
Did you pass it?
Yeah, I passed it, but it's a fun challenge because there's so many ways to do it, and there's some people that do it like in machine language. It's like 20 bytes or something. You know, like you can get really efficient solutions, but your first solution is going to probably be inefficient and be messy, and then you can try it again and say, how would I do it? Because you know, when you first approach it, there's a lot of things that you run into that you don't think about at first, but it's a neat challenge that you guys might want to, if you're ever bored, just try to make a program that output is itself and it has to be a non-empty source code. You can't just say, okay, I've got an empty file.
It works. Yeah. Compiles, but does it run the test? So did you do TBD on it?
No.
Could you?
I guess I could now, but
Okay.
yeah.
So
I might approach it again. So
that's another interesting aspect is you get a program, you got a solution, and you write it out. It's kind of like, you know, my character counter there. I'm just taking it for granted the character counter is going to work because it's got to be worked, right? It's just, you know, is the file got something in it, and give me the next character and increment my counter. But then you saw with the other thing, the replacement of a character within a string. If I didn't write the test case to see, you know, inputs and outputs, I would actually, you know, I didn't know what was going on. And so I thought it was part of the casting aspect. And so I, you know, recasted everything. But it turned out it was actually just possibly not using the API correctly, or not understanding that if you insert a single character with a start and finish of the same, it doesn't do the right thing. It does something different. Anyways, cool. Well, thank you all. If there's no other questions, call it a night and go home in the rain.